Question 3, exercise 10J. That's the function there. We've got to find the first derivative. First derivative, we'll just rewrite that a bit easier than using the quotient rule. E to the x times e to the minus x to the minus 1. So we've got e to the x, the first one, times the derivative of the second, which is minus 1 x to the minus 2, plus the second times the derivative of the first. We'll resolve that. Okay, so that's the first derivative. Part 2 is the second derivative, so we're going to use this. Again, we're going to rewrite it using the indice form here in a minute, just up here. Okay, so that's ex times x to the minus 1 minus ex times x to the minus 2. And we're going to take the derivative of that to give us the second derivative of this function here. Okay, so it's the first one times the derivative of the second, plus the second one times the derivative of the first, and then that's that term, and then we're going to do the same with this term, so it's minus the first one times the derivative of the second, and we've got plus that one times the derivative of the first. I put the minus sign in here. Okay, that's from there. Okay. Now that becomes, each term has a e to the x in it. So we're just clearing up all of this. Okay, then we'll factorize e to the x out. Okay, so that term is what remains from that, with e to the x factored out. Then these two are like terms. So we've got two of them. Good. Okay. We're putting everything over x cubed, so that would be multiply the top and bottom by x, multiply the top and bottom by x squared, and leave that by itself. Common denominator is x cubed. So we've got minus, we're going to put x squared first, then minus 2x plus 2. Good. Let's have a look at B. It says, hence show that there is a minimum point. Well, a minimum max occurs at a turning point, and a turning point is when the first derivative is equal to 0. So we're going to equate this to 0. Now they've already told us to use this point x equals 1, so that makes it a little bit easier. We just say at x equals 1, and you can see if you put 1 in here, then it's true that there will be a maximum or minimum there, because this term becomes 0, so that satisfies that. The left-hand side would equal the right-hand side. So we know there is a turning point. Now, is it a max or is it a min? That was the question. Well, the question was show that it's a min. Okay. So if the second derivative is greater than 0, it's going to be a minimum. And if the second derivative is less than 0, it's going to be a maximum. So all we need to do is to put 1, they've asked us a 1, into the second derivative. Now that's the second derivative there. So we're going to put 1 into that. So it's e to the power of 1 times 1 squared minus 2 times 1 plus 2 all over 1 cubed. And that comes down to e times 1, which is e. Now e would satisfy this one, it's greater than 0, so hence it is a minimum. Okay, so that's that part. Part C, prove that there are no points of inflection on the curve. Points of inflection occurs where the second derivative equals 0. So we're going to have a look at that. So we're equating this second derivative here to 0. We're going to use the null factor law again to solve this for x if we can. Now, this never equals 0, as you know from the curve, from the graph. You graph that, you'll see there's no x value for when that equals 0, so that's not possible. This top part here, if that equals 0, this would equal 0, so we'll use the top part, and we're saying, okay, if this equals 0, so we use the discriminant b squared minus 4ac from the quadratic formula. That's underneath the square root sign, and that is a negative number. Okay. Now I've seen that, so if that's negative, therefore there's no real solutions because the discriminant is negative. Can't do the square root of minus 4. Hence, no inflection points.